Hi, 7th grade. Welcome to lesson 8.3, Draw Triangles with Given Conditions. By the end of the lesson, I want you to be able to say, I can draw triangles when given information about their side lengths and angle measures. Solve and discuss it. Kane has 4 pieces of wood available to build triangle-shaped garden. Which pieces of wood can he use? We will pause and use some of the cutout wood that I have to see what triangles we get, then get some participation. Okay, so hopefully we got some options where we had the 2 foot plus the 3 foot and then the 4 foot, or the 2 foot with the 5 foot and the 4 foot. And I'm sure there was other ones, but I really hope that no one said 5 feet with the 3 feet and the 2 feet, because that won't ever make a triangle no matter how hard you try. Are there any combinations of the 3 pieces of wood that will not create a triangle? Oops, there it is. Explain. Because the 2 smallest sides added together have to be greater than the 3rd side. All right, example number 1. Draw triangles with given side lengths. Students in woodshop class are measuring the cutting out of a triangle base for a corner shelf, with sides measuring 6 inches, 8 inches, and 10 inches. How can you determine if all the students would cut out the same triangle? Explain. So they used geometry software and they showed us 3 different combinations of where to put each piece of wood. But in each combination, it's still the exact same triangle, because you can turn the triangles so they fit exactly on one another. Turn or rotate. Triangles with the same side lengths are the same shape and size, no matter how they are positioned. So students will all cut out the same triangle. How many unique triangles can be drawn with given side lengths of 8 inches, 10.3 inches, and 13 inches? Only one unique triangle can be drawn with the given side lengths. They give you all 3 side lengths, so given 3 side lengths, there is only one triangle. When 2 sides of a triangle are switched, why is it still considered the same triangle? Because you can rotate or reflect, and they are still congruent. Example number 2. Determine possible side lengths of triangles. Steve gathers 3 pieces of wood from the scrap pile in woodshop class. Can Steve make a triangle with these 3 wood pieces? Explain. Well, remember what I said before, the 2 smaller sides added together, 3 plus 4 equals 7. It has to be greater than the 3rd side. Is 7 greater than 8? No, it is not. This is no good. This is not going to work. It's not going to form a triangle. As you can see here, they won't connect, the 3 and the 4 foot one. What can you conclude about the lengths that make a triangle possible? The sum of the lengths of the 2 shortest sides must be greater than the length of the 3rd side. So 3 and 5 wouldn't even work either. It has to be greater than 8. Draw a triangle with a combination of given side lengths and angle measures. Can more than one triangle be drawn with the following conditions? Side lengths of 5 inches and 6 inches with an angle of 45. So you draw a 45-degree angle with the line segments, then connect. Side length of 6 inches with angles at each end measuring 40 and 60. Draw a 6-inch line segment with rays that form 40 and 60 angles and extend. So only one triangle in both of these cases can be made. So if they give you 2 sides and an angle between, you can only make one triangle. If they give you two angles with a side between, that's also only one. Okay, so let's try it. Write 3 side lengths that will form a triangle, and write 3 side lengths that will not form a triangle. So let's look for some participation. Will form could be something like 3, 5, 7, because the two smallest sides, 3 plus 5, is equal to, we'll do this in a different color, 3 plus 5, oh, thinking ahead of myself, 3 plus 5 is equal to 8, which 8 is greater than 7, so that works. So will not, different color, Miss Jessica, will not form a triangle, be something like 1, 2, and 5. Because 1 plus 2, the two smaller sides, equals 3, which is not greater than 5. Can a triangle be drawn with a side length of 3 inches and angles at each end measuring 90 and 89? Well, 90 plus 89 is equal to 179, which we know a triangle is 180 degrees. So angle 3 could equal 1 degree. So there's a triangle with 3 angles. Yes, the third angle is going to be 1 degree. Because remember, all 3 angles in a triangle add up to 180 degrees. Example number 4. Draw a triangle with 2 given side lengths and a non-included angle measure. So that means an angle that's not between the 2 given sides. Can more than one triangle be drawn using 2 side lengths of 6 units and 9 units and a 40-degree angle that's not formed in their intersection? So here's your 60 and here's your 6 and 9. And then your 40-degree angle. Notice that the 40-degree angle is not between those two. So you can make a triangle like this, where the 6 units is AB, or you can make another triangle where AB, this is 6 here. So that still works. So more than one triangle can be made with the given measure. So in the opposite way, the other one, so if we have 2 side lengths and a non-included angle, so an angle that's not between them, gives you more than one triangle. Draw a triangle with 3 given angle measures. Is there a unique triangle with angle measures 30, 60, and 90? So they drew a 30, 60, 90 triangle for us, but if you enlarge and reduce the triangle, they're all different triangles, but they still have the same angle measure. So if you're given 3 angles and no side lengths, you can have more than one. Can more than one triangle be drawn with 2 side lengths of 6 inches and a non-included angle of 60? Well, here's 6 inches and here's 6 inches. What kind of triangle is that? That's called an isosceles triangle, meaning two sides are the same. But if we have 2 sides that are the same, that means we're going to have 2 angles that are the same. So those 2 angles have to be 60 degrees. 60 plus 60 gives us 120. If we subtract that from 180, that's going to give us also 60, which means this is an equilateral triangle. So no, only one triangle can be drawn, because we just found that third angle is 60, meaning now we have 2 sides with an included angle, which from the page before we saw that only gives us one triangle. Key concept: you can analyze given conditions of side lengths and angle measures to determine whether one unique triangle, more than one unique triangle, or no triangle can be drawn. So on the left-hand side here, there's more than one possible triangle. On the right-hand side means there's only one, if those conditions are given. So there's only one triangle if they tell you all three sides. There's only one triangle if they tell you a side, an angle, and a side. There's only one triangle if they tell you an angle, a side, and an angle. But if they tell us only three angles, it could be a bunch of different triangles. If they tell you two sides and one angle that's not between the two sides, it could be more than one triangle. Alrighty, 7th grade. Yeah, 7th grade. Let's say it. If we can get to it. Let's say it. I can draw triangles when given information about their side lengths and angle measures. Have a great day.